Even and odd functions. We say a function is even if you replace all the x's with a negative x, it doesn't change the function. The function stays exactly the same. So replace every instance of x with a negative x into the function and nothing changes. You have yourself an even function. That means that if you graph the function, you'll have symmetry about the y-axis. Anything on the left half of the graph will also appear on the right half of the graph, with the y-axis right down the middle. So for an even function, if you know the point AB is on the graph, then the point negative AB will also be on the graph. An example. Consider f of x is x squared. Let's check and see if this is, in fact, an even function. So to check that, we calculate whatever this thing is, f of negative x. If we get back exactly the original function, we've got an even function. If we don't, then it's not even. So f of negative x means replace all the x's with a negative x. Now what happens when you square a negative? Squaring a negative becomes a positive. So that negative just disappears. We get x squared. But wait a minute, x squared, that's the original function. So when we put in that negative, nothing changed. We get the original function back. X squared is an even function. And, hey, look there. That's an even exponent. Coincidence? I don't know. So this is an even function. We can see that on the graph. We have symmetry about the y-axis. The y-axis cuts the graph right down the middle. Everything over here is also over here, and vice versa. So, for example, the point 2, 4 is on the graph. Since it's an even function, the point negative 2, 4 should also be on the graph. Changing all the x's to their negative versions should still live on the graph. Yes, negative 2, 4 is on the graph. Okay, we say a function is odd if when we replace all the x's with a negative x, we get the opposite of the function back. Everything changes to the opposite sign. So we replace all the x's with a negative x. We get back the original function changed completely. The opposite of the original function. Odd functions are symmetric about the origin. Any point we have in one quadrant, say quadrant 1, will have reflected in quadrant 3. Anything in quadrant 2 will be in quadrant 4. So that means if you have a point AB on your graph, and it's an odd function, the point negative A, negative B will also be on the graph. Let's consider y equals x cubed. Check and see if he's odd. So we plug in a negative x, replace all the x's with a negative x. If we get back the original, if nothing changes, we would have an even function. That's not going to happen here because I wrote this problem and I know it's not even. That's not what we're checking for now. We're checking for the oddness though. If we get the opposite of this back, we have an odd function. So we replace the x with a negative x. When you cube a negative, you have 3 negatives. 3 negatives multiplied together is a negative. So f of negative x is negative x cubed, but that's the opposite of the original. We've got ourselves an odd function. Notice that this odd function has an odd exponent. Coincidence? I don't know. Odd functions are symmetric about the origin. Any point that we have up here in quadrant 1 also exists down here in quadrant 3, reflected about a line through the origin. So the point 2, 8 is on this graph. 2 cubed is 8. Since it's odd, if I replace that 2 with a negative 2, if I come over here, I should also have to change the y value to a negative 8. And hey, look, the point negative 2 Negative 8 is also on the graph. Okay, let's do some examples. We got this function. We want to determine if it's even, odd, or neither. It doesn't have to be one or the other. So the first thing people look is they say, oh, well, 3 is an odd number. I don't care about the coefficients. Coefficients aren't going to change anything. What I really want to check are all the exponents. That's an even exponent. That's an even exponent. What's my exponent here? No, it's not 1. You're thinking it's 1. It's not. How many x's do I have here? I don't have any. That's x to the 0 power. 0 is an even number. This has all even exponents. I bet it's going to be an even function. So we replace all the x's with a negative x. If all those negatives disappear and we get back exactly this original, we've got ourselves an even function. So a negative to the 6th power, any even power is going to kill that negative. This negative to the 4th power, gone. So this negative x to the 6th just becomes 3x to the 6th. This minus, we didn't do anything to this minus, it comes along for the ride. Negative x to the 4th, a negative to an even power, is a positive. And then the plus 7, we didn't do anything to that. So g of negative x is 3x to the 6th minus 5x to the 4th plus 7. That's exactly the original function. That's the definition of being an even function. Okay, what about this example? Again, if you're really quick, you can just notice we've got all odd powers. X to the 5th is an odd power. X cubed is an odd power. X to the 1st is an odd power. If we have all odd powers, we're going to have ourselves an odd function. But let's check it. Replace all the x's with a negative x. If we get the original back, it's even. If we get the opposite back, it's odd. So, a negative to an odd power, there's an extra odd. That doesn't kill the negative. Negative to an odd power keeps the odd. So this negative, This negative x to the 5th power is negative 4x to the 5th. A negative cubed is still a negative, which will cancel out this negative in front of the 2. We get a plus 2x cubed. And then plus 7 times negative x will be negative 7x. So here's our original function. Positive 4, negative 2, positive 7. Now we have negative 4, positive 2, negative 7. All the signs changed when we plugged in that negative x. That makes it an odd function. We got exactly the opposite of the original function back. One more example. Let's look at this guy. 3x squared plus 5x minus 4. If you're really quick here, you notice we've got an even exponent, an odd exponent, and constants, remember, are even exponents. We've got a mixture of even and odds. Anytime that happens, if you've got a mixture of even and odd powers, it's going to be neither. But let's check it. Replace all the x's with a negative x. So, 3 negative x squared minus 5 negative x minus 4. Squared is going to kill that negative. Here, this is to the 1st power, so we'll get to keep that negative. We didn't do anything to the minus 4, it just comes along for the ride. So f of negative x is positive 3x squared minus 5x minus 4. That's not the original. That 5 changed. So it's not even. To be even, everything stays the same. This is not odd because for odd functions, everything changes. This 3x squared didn't change, the minus 4 didn't change. This is not the opposite of the original, so it's not an odd function. If it's not even or odd, it's neither. That's it.